So, good morning, Paw Patroller. This is Teacher Tiara. How are you today? Are you feeling good right now? Kindly heart react, please. Okay, that's good. Thank you for that. Now, after a long day of first mission, we had our last meeting with Teacher Faith. Let's take a break first, okay? Okay, so, who wants to be a rider? Anyone? Okay, let's have Shane. You'll just read that on
Okay.
the screen.
Okay, teacher. Hello again. I'm Ryder. I would love to make soup for you all. Do you want to help me prepare our food? But before that, I need something to cook our food. Do you know what we need?
Oh, Ryder is asking. So Ryder asks what we need in order for us to cook our food or soup. So anyone from the class, what do we need? Yes, Alinda, how?
I think we need a gas stove, teacher.
A gas stove? Are you sure? Let's see if it is a gas stove. Next click, please. Very good. It is a gas stove. So let's give her a confetti reaction, everyone. Yes. And what form of energy does gas stove produce? Okay, let's have Connie.
Is it a heat energy, teacher?
Heat energy. Let's see if it is a heat energy. Good job, Connie. It's indeed a heat energy. So, let's give a heart reaction, everyone, for Connie. Okay, that's right. So, do you know what is heat energy or what comes to your mind when you hear the word heat energy? Okay, let's have Trixie.
Something hot that has lots of energy, teacher.
That's right. Very good, Trixie. So, heat energy, it is the energy that makes things hot, right? So, it caused by the movement of tiny particles called atoms and molecules. So, the faster they move, the hotter the object becomes. Next slide, please. So, who wants to read? Okay, let's have Isa.
Okay, teacher. Heat, it's a form of energy. It is the result of the continuous motion of small particles that compose all matter.
Thank you for that, Isa. So yes, so heat energy, it is a formal energy also known as thermal energy. So when a material is heated, next slide please. So yes, as you can see, there's a material there. So when a material is heated like this one, um these tiny particles that which is in the right side, which is what we call the molecules. Next click, next click please. That is a molecules. So if back please. Let's go back. Yes. Thank you for that. So when a material is heated, these tiny particles, which is what we call the molecules, vibrate faster. And if the molecules absorb more heat energy, it vibrates even more faster. As a result, the temperature will rise. So heat energy between two objects that are different temperature, like you've seen here in the picture. So from cooling to heating, from heating to cooling. So you don't have to worry about this one because it will discuss further by our next teacher. So speaking of temperature, what is temperature, teacher? So when we say temperature, next slide please. So it is the measure of how hot or cold an object is. So when it is hot, um, the temperature is going too high, and when it's cold, the temperature is low. Now let's proceed to the sources and uses of the heat energy. Okay, next slide please. Next slide please. Okay, so we have here the first source of heat energy. So solar energy. Solar energy or the sun is the major source of heat energy, right? So, um, do you have any idea what is the use of um, the sun, or what is other use of the sun? Yes, Lisa?
I think from the picture, teacher, we can see a solar panel there, and the sun generates into electricity.
Yes, very good, Isa. Next slide, please. Next click. Yes, that's right. So the sun's energy travels to Earth as an electromagnetic radiation. So, what is electromagnetic radiation, teacher? What do we mean by that? So when we say electromagnetic radiation, class, it can be vary in strength from low energy to high energy. Yeah. So, um, these waves have both electric and magnetic parts, and they come in different types like visible light, radio waves, and X-ray. So this one also will be discussed by the next teacher as well. So the amount of radiation that coming from the sun, which is this one, coming from the sun, it also depends on the time of the day and the season, but it is constantly enough energy to support life as well. So, just like what Isa said, a solar panel uses the sun's light or heat energy to generate electricity, right? So now here are the example or uses of the sun's from heat. So we use this for drying our clothes, to generate electricity as well. So do you have any other idea or example for this? None? Okay. Oh, okay, let's have Shane. Yes,
Um,
Shane. Okay,
yes, teacher. I'm sorry.
okay.
I had a technical error. So
Okay,
I
that's
believe,
okay.
teacher, this one uses of the sun, teacher, is to give us vitamin D, teacher.
Yes, that's right. Very good, Shane. Let's give Shane a heart reaction, everyone. Yes, that's right. Now let's proceed to the next source of energy. Oh, we have here the geothermal energy. What is geothermal energy? So as you can see in the picture here, there's a like a bowl with a very hot metal inside our planet. And that is what we call the Earth's interior or Earth's core. Next slide, next click, yes. So the geothermal energy is comes from within the Earth, and the heat is produced within Earth's core, which is the solid iron surrounded by a molten lava. And did you know that the Earth's core is hotter than the surface of the sun? So can you imagine that? How hot the Earth's core than the surface of the sun. So the energy is produced by a radioactive active decay of particles of rocks creating the magma. So take note for that, everyone. So people use this geothermal heat by utilizing hot springs or underground water to heat our homes and buildings. Yes. Now here are the uses. Next slide, please. So here are the uses of the geothermal heat. So yes, so it used for hot spring, which is used as spas, heating water at fish farms, provide heat for building, raising plants in greenhouse, specifically for drying crops, and provides heat to industrial processes. So for the third source of heat, next slide. So we have here the fraction. So I know that you are already familiar with this, as this was discussed by our previous teacher, which is teacher DJ, right? So can someone give me the definition of fraction? Okay, can I have Isa?
I, friction is caused by rubbing two objects or things, teacher.
Okay, that's right, Isa. Can we all give Isa a heart reaction, everyone? Okay, that's right. So friction, it is when two surfaces rub against each other. Next click, please. Yes. So the energy from the motion is converted into heat energy due to the interaction between the rough surfaces. So last meeting with teacher DJ, we are demonstrate a kind of friction, right? Do you still remember it? Like rubbing two hands. Right. So next slide, please. So we have here an examples of the friction. So as you can see, there's a match there, but unfortunately, we will not be able to demonstrate this using a match. Considering that you're only a grade 3 pupils, but we will do another way of friction. So may I request everyone to please um, open your cam. Okay, so kindly follow me as we will do the demonstration about the fraction. So, may I see your both two hands? Yes. So we will rub this like this one and count 1 to 5. Okay. Okay. 1, 2, 3, 4, 5, and I want you to put that on your face. Place that on your face. Yes, that's right. So okay, you can off your cam now. So after doing that, children, what have you observed? Yes, Connie.
It's kinda warm, teacher.
Yes, very good. It has a warm or heat. Very good, Connie. Let's give Connie a confetti reaction, everyone. So yes, because of the rubbing we did, which is the one that which is as we rub our both hands, it is the time that we produce the heat or the our hands become warm, and that is what we call the fraction, everyone. So next slide is the fourth source of the heat energy, which is the biomass. So when we say biomass class, it is more likely an animal or and plants products that give us a natural source of heat energy. So like for example, when we eat hamburgers, like there's a patty or meat, right? So that is a um, uh, um an animal source or product. And when we eat a garden salad, there's a plant there, right? So That is an example of plant source or product. So why was that, teacher? So is it because when we eat them, we can get a heat energy in a form of calories? Yes. So which is that give us fuel. So in that way, it gives us fuels. So another example is when we when we burn a type of plant like such as trees. So we created heat or fire, right? You agree?
Yes, teacher.
Yes. So and that and the heat energy from the biomass, which is the plants and animals products, is um that is what we call the biomass because of the product created from it. So the heat energy from biomass is originally from the sun. So um this one is also discussed by teacher Faith. And I want you to recall for this that plants use the heat energy from the sun direct to grow so that it will grow through the process of photosynthesis. And the animals eat plants to get energy. And we as humans, we also eat plants as well as animals for us to get what? To get
Energy, teacher.
Yes, very good. To get energy as well. Now, here are other uses of the heat and biomass. Next slide, please. So, we use heat to generate electricity, like we create generator as well, and we use it to make plastics and other products as well. Now, for the last source of heat, next slide, please. So, yes, we have here the fossil fuel. So, are you familiar with these examples on the screen? Kindly heart you up. Yes, of course, we are all familiar with this. So, solid fuels like coals, like this one, and gaseous fuels such as petroleum are also a natural source of heat energy. So these fuels are created over million years from the remains of animals and plants. So we find them in deposits beneath the surface of the earth. So when humans ignite fossil fuels, the fuels will going to combust that creates a heat energy. So here are the uses of heat energy in fossil fuels. So we have there it used for transportation, right? So it we use gasoline for the for cars and flames, lighting and cooking our food. So do you have any example or specific example that you have in your home or the use in heat and fossil fuels? Anyone? Okay, none. Okay, that's right. Okay, that's okay. So speaking of cooking our food, so earlier we cook our food, right, or soup.
Yes, teacher.
Yes, that's right. And now it is time for us to eat. Next slide, please. Yes, it is time to eat. So while Ryder and his friends are still eating, let's play a game first. So do you want to play a game?
Yes, teacher.
Okay, thank you for that. Now it's time to become a heat detective. Yes, let's be a heat detective. So next slide, please. So I have here a picture, and I want you to observe and identify which objects produce heat. So we have there are 6 objects. Okay, let's have Trixie.
Flat iron, teacher.
Okay, we have already one. Let's have Daisy.
The kettle, teacher.
Yes, Tito. Next is let's have Irana.
Casting oven, teacher.
Very good. We already have 3. Next is Mobinga.
The sun, teacher.
Yes, the sun. Very good. Let's have Daisy again.
The lamp, teacher.
Yes, the
The
lamp.
lamp.
And the last one. Okay, Trixie. Go ahead, Trixie.
Gas stove, teacher.
Yes, okay. Let's see if you got it right, everyone. Next slide, please. No, no. Okay, very good. So let's give ourselves a round of applause or clap reaction. Very good, everyone. Okay, thank you. So next slide, please. So, Ryder has a fun fact, I mean. So, did you know that when objects are heated, they expand? Eiffel Tower grows taller when it's hot during summer. Oh, now we know. So, they said that the metal will expand if it is heated. So, the best example for this is the Eiffel Tower in Paris because of the material used. Yes. Now let's go to another adventure in Adventure Bay. So are you all excited? Can we heart react? Yes. So next slide please. Oh, Ryder is back, but it is already dark. What do you think can turn the lights back on? Okay, can we may have Shane?
Electricity, teacher.
Electricity. Let's see if it is electricity. Very good. It is indeed an electricity. So what comes to your mind if you hear the word electricity, children? Okay, let's have Trixie. Okay, go ahead, Trixie.
Electricity is the flow of the electric charge, teacher.
Very good. Let's give Trixie a heart reaction, everyone. Very good. So electricity, it is a flow of electrical power or charge. So it is also both a natural phenomenon and a highly utilized source of energy. So it is a form of energy that plays a vital role in our modern world. So we have here another information about electricity. Next slide, please. So yes, so electricity, it is a secondary energy source, meaning it can produced by converting other forms of energy like coal, nuclear energy, natural gas, solar energy, and so on and so forth into electrical power. And also, electricity is considered an energy carrier. So this means that it can be transformed into other form of energy such as mechanical energy like in motors or heat like in electrical heaters. So for your confusion everyone, so the differences between the two is that the secondary energy is to produce by converting other source of energy, while the energy carrier is the one that it can be transformed into other source of energy. And then electricity has drastically changed our daily life. So do you agree with that? Electricity has drastically changed.
Yes, yes, teacher.
Yes, of course. because electricity powers our homes, our businesses, transportation system, and it also for communication and entertainment and so on and so forth. That is why electricity it it is important in our daily life. So for the next slide, we have there a renewable and non-renewable energy. So do you know what is the difference between the two? Okay, let's have Daisy.
Yes, teacher. So, renewable energy are sustainable, while the non-renewable energy sources are limited.
Okay, thank you for that, Daisy. Let's give Daisy a confetti reaction, everyone. Yes. So when we say renewable energy, it is infinite, meaning it can be replenished over time without running of supply. Unlike to non-renewable energy, it is finite, meaning it will eventually running of supply. So it is not forever. Yes. So now let's proceed to the sources and uses of electricity. So for our first source of electricity, next slide please. Okay, so can someone please read? Okay, can I have Isabella?
Yes, teacher. Nuclear energy is a non-renewable energy source that uses the process of nuclear fission to produce thermal, kinetic, and then electrical energy.
Okay, thank you for that, Isa. So nuclear energy or nuclear power plants. So are you familiar with this? Nuclear power plant? Can you have react? Or no? Okay, so when you say nuclear power plants, it produces electricity as well. So from the heat created when atoms are split within a nuclear reactor, that is what we call the fission. So take note for that the process of nuclear is nuclear fission. So, nuclear fission, it is the splitting atoms. So, it produces heat, which is then used to generate steam. So we are using nuclear energy to power our homes and businesses through the electrical grid, which is this one. So for our next source of electricity, next slide please. We have there the hydropower or hydroelectric power. So can someone please read? Okay, let's have Shane.
Hydropower takes advantage of naturally moving water like rivers and ocean tides.
Okay, thank you for that, Shane. So hydropower, hydroelectric power uses the energy of falling water to generate electricity. So with the uses of the flow of water from dams and rivers, it turns to turbines and generate electricity. So how it works, teacher? So it works by falling or flowing water spins a turbine connected to a generator. And also like for example like in dams. So are you familiar with dams, everyone?
Yes, teacher.
Yes, so dams it creates reservoirs, so it allowing for controlling release of water to power turbines and small hydropower. It is a smaller scale facilitates can use the natural flow or rivers and streams as well. Next is the third source of energy of electricity. Next slide, please. So we have here the wind power. So wind power, it takes advantage of natural movements on Earth. So when we say wind power, it is the wind turbines that capture the power of the wind to generate electricity. So how it works? So when turbines convert the kinetic energy of wind into mechanical energy which drives a generator. So when we say turbines class, it has blades that rotates in the wind, just like in the picture, which spins a shaft connected to a generator. So for the next source of electricity, we have the solar power. So it is also a source of the light and the heat energy, right? And also it is a source of the electricity as well. So solar cells or solar power convert light energy from the sun into electricity. So we have what we call this photovoltaic cells, which is these cells directly convert sunlight, which is the sun, into electricity, like what I have mentioned in the heat energy a while ago. So also it is a solar thermal as well. So heat from the sun is used to generate steam, which then drives a turbines as well. So um like in the solar panel, so it is, although it is a quite expensive, but solar panel, it is infinite, like what I said earlier, it's infinite, so it can replenish over time, so it will not be running out of supply. So yes, it is a big advantage and has a lot of benefits as well. The next slide is the, yes, geothermal energy. So can someone read the geothermal energy? Yes, Daisy.
Geothermal energy is energy formed from heat beneath the Earth's surface.
Yes, thank you for that, Daisy. So geothermal energy, it is also the source of heat energy, right? So but this time it is used to generate electricity by pumping a water from underground to the houses and buildings as well. So it works when heat from the Earth's interior is used to boil water or other fluids, and that is the moment that we create steam that drives to a turbine as well. So they are all connected. So hot, like high pressure fluids from deep underground, which is this one, are flushed into steam when they are released to a lower pressure. So do you understand, everyone? Okay, kindly heart track. Okay, thank you for that. Now let's have the second to the left, which is the biomass. So biomass energy generate electricity as well. So it includes woods, agriculture waste, and municipal solid waste, just like in heat energy, right? So it can be born to create steam that generates electricity. So the term biomass, it encompasses a large variety of materials. So like agricultural residues and animal and human waste as well. So that can be converted into electrical power through several methods as well. Now let's have the last source of energy. Next slide, please. So the fossil fuel. So can someone please read? Okay, Isabella.
Yes, teacher. Fossil fuels are chemical energy sources like oil and coal formed from the remains of ancient organisms.
Yes, thank you for that, Isa. So yes, fossil fuels is also a source of electricity, like coal, natural gas, and petroleum are the that are born to generate electricity. So burning these fuels, children, it creates also a steams that spins the turbines connected to a generator, that which is produce a electricity. Now here are the uses of the electricity. Next slide, please. Next slide, please. Tricks. Okay, next slide, please. So here are the uses of electricity. So we use it for lighting, heating, cooling, refrigeration, operating appliances, and public transportation system. So do you have any example or uses of electricity that you have in your home? Like appliances that use electricity. Anyone? Okay, yes, Isabella.
Like charging devices, teacher. Charging phone.
That's right. Charging devices. Let's have another one. Let's have Trixie.
Watching TV, teacher. It needs electricity.
Yes, very good. So all of your answers are correct. Now that we are done, knowing that what are the sources and uses of electricity. Next slide, please. So yes, thank you, kids, for helping Ryder. Okay, next slide, please. So we have a fun meme here. So what do you think is the electricity reaction, everyone? What is the reaction of electricity after hearing those words from Facebook, Google, and internet? Yes, Isa.
I think electricity is disappointed, teacher.
Yes, that's right. It looks like she is disappointed, right? Okay, so thank you for that, everyone. Now it's time for next slide, please, to have a quiz. So, yes, thank you, everyone, for coming.